Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Corey.
And he's not Allison.
No.
And he's not even Corey, too.
No, I'm Corey. I'm the original.
He's the original Corey. Welcome back. Another live edition of the Bill and Corey Show.
Yes, yes.
We got a special guest today. We had a benefactor.
A benefactor.
Get us. Not new. It's old. So this is an
found
old,
at the bottom of the ocean, I think. From the Titanic?
Ocean of eBay. This is a stage regulator, probably a mile 8.
Oh man, he has the East Rutherford address.
Yeah,
on
it's
there.
really kind of
Wow.
neat. It's got some neat stuff. Oh, zoom in. This is zoom-inable. So yeah, it's got some old stuff. East Rutherford, New Jersey, Joliet, Illinois, Newark, California. Oh, California must have been a state back then.
Yeah, wow.
So
this was after 1849.
Yes. This regulator's from the 1960 to 64 range. That's our best guess. That's got I think the original Matheson logo on there, which is a cylinder, and it says,
"Oh wow,
Matheson Company." You can't see it under there.
And like a nice little.
Yeah.
It looks old timey.
It is old timey. So yeah, this is going to be in our carefully curated museum, and this has got our.
No, we're not putting it on eBay.
No, we're not. No, we freed it from eBay, and you have to
have our annual Rotary fundraiser. Well, we might.
Okay. Anyway, so we're going to show this here. This is really cool. This is going to be our headline piece. I'm going to have to get some security now.
Lasers?
Yeah, lasers. Just
Triple
like,
R's,
yeah, something like that. Okay, we do have...
Yes.
Okay, here we go. This one's for Corey. I wanted to follow up on this one as our customer ended up ordering 2 of these regulators. That's the 3510 series. We'll get to that. That's not the regulator.
I know, but it'll do. It doesn't.
What we got graphics for this.
Oh, graphics for this? I thought we were
or you wanted these 2 regulators. They're mini regs. Okay, one for ammonia, another for sulfur dioxide. We won't tell you what they're going to be used for. Squeak, squeak. They just reached out and mentioned that there's gas coming out of both. That's a good sign. But they're able to move the dials on either regulators one way or the other. They provided the attached pics of their setup. We're going to show you some edited pics, just shrunk down. Any idea on what the issue may be and what they're describing?
Yes.
No. Okay, so you want to put up a graphic number 1. So this is their setup.
And
sulfur dioxide.
Looks normal, right? I mean, they have it put in. They said gas is flowing through. So
this is pneumonia anhydrous.
You saying pneumonia? You're gonna mess me up.
I didn't do that just to mess you up. Okay, so that's our setup. Those are our mini rigs. Steel lecture balls. There's plastic tubing going out, so I'm guessing it's a low pressure application, probably flowing in some kind of chamber, which I'm right.
Application, high pressure application, which brings us to the problem.
Okay, you want to pop up the next graphic? There's a little close up of the gauge.
So as you can see,
moving.
No.
And so why aren't they moving, Corey?
Well, for ammonia, so when you're using gases, everybody always it's in a cylinder. Gotta be
2,000 psi.
3,000 psi, right? Well, some.
Oh, go back to keep for this.
Yes.
There we go.
Some gases, though, at certain pressure, become liquid. And can you pressurize it, Bill?
Oh, the pump.
Well, I mean,
not in your cylinder.
You can't compress a liquid. You can't compress. So they become liquid, and then it can only get certain pressures. Yeah. It's 34. And that cylinder is only 114 psi. Look at the gauge on the picture or the dial. It goes to 3,000. It's plus or minus 323. Right?
So it's plus or minus 90 to start with, and that first see above that gauge on the right is 100.
It's 100. So
it's reading nothing.
Yeah. So even though something's coming out, it's probably about 100 psi, depending on the temperatures and stuff.
Depends on the temperature. So you see nothing on that.
You see nothing on that, but there is gas coming because of how big the scale is for how small the pressure is.
Yeah. Now, how come it's not coming on a delivery side?
Well, In this case, we had to do a little bit of looking at the photo closely to figure out where it was going. And if you're flowing out, and this is what appears from the picture, is they're flowing in the atmospheric pressure, which is 0 psig.
Yep. Yep.
And therefore, there's no back pressure for the. So right now, opened up the cylinder.
Yeah. Well, it regulates it down.
It regulates it down a little bit, a little bit.
Yeah, so it's going to atmospheric pressure.
So you're not going to see anything on the dial.
Yeah.
Because there's no back pressure on it.
Yeah, so you need some kind of back pressure on there.
And it's called droop, like you said.
You could call it that is droop. It's just wide open.
It's just wide open. So
yeah, you can take the graphic off.
Yeah.
Oh, this will be fun. And Corey gets this one up off the ground.
Well, talking about the heavy plate's not on it, so that makes it.
Yeah, and I'll take it over once you bring it up. Customers switch over with economizer to be used with only with 350 peters. Also, they're cryogenic containers. So they like to be able to use
a naked one.
We
There's
took
no
it.
panel in the back.
It's still warm. It came off the production area. Our technician was working on it, and it's not complete. Doesn't have a back plate, so setting of things. So this one is for liquid dewar, cryogenic liquid dewars.
Mm-hmm.
So this one actually is for a 350 psi dewar, and the bottom's economizer. And what this is, it's really a back pressure regulator. You can think of it as a relief valve. So liquid dewar, it has a vent. So when it gets warm, it warms up. And gas. So you got something like argon, which is expensive. You don't want to waste that stuff. Use it.
You want to be economical.
Economical. That's
yes,
right.
Yes. Hence the name.
So the economizer is like a relief valve. This
the
is
economicalizer. That's what it's called.
This is set for 330 to 340 psi. When the dewar starts getting hot, it bypasses the switchover. You really can't tell, but this is kind of like a relief valve. You got check valves to replace both sides. The dewar gets hot, that one will be in use instead of, even if it's on the backup side, you're going to use that. So you could have the arrow turn wherever it's turned. It's turned to this side, and
the other dewar gets warm.
The other dewar gets warm, so it'll bypass the regulator. It's piped in there. It's magic, and it'll come on the other side of the switchover regulator. So it bypasses your switchover regulator. So if they would, we want to use it for high pressure cylinders. Well, high pressure cylinders are above 350 psi. So
as it currently stands, my answer was, well, you can't do it with the current setup.
And I said, yes, you can.
But you have to set up, so I thought sneaky.
Okay. You can play that one. Okay. So what we have here is you want to have your cylinder look like a dewar for pressure. So this is actually a line regulator, but it's a single stage regulator. So you'd put this on this is for argon. So this would go in argon cylinder. And this is outlet bushing, a CJ580 outlet bushing. So you would take your hose here, it's all capped off properly. You detach the cap. Attach the hose on there just like you're hooking up to a cylinder.
Can you use it as a Teflon seal?
No.
No?
This is, yeah, so the hose would go in here. This is a check valve. It's got integral check valves. You don't have that. And this is preset. This will be preset for this situation.
Wait. We would put an integral check valve on that?
Yeah.
Even though there's one already.
Yeah, because you want to have it right at the connection. Okay. That's it. That's why I did that.
Okay.
It was a engineer.
Double check.
So we took the knob off. You see the knob's not on there, and we locked.
Because there's no point. You don't want to adjust it. You want
You don't want to mess things up.
Yeah, you don't want to mess things up.
So this is set for 300 psi. So it won't have any problems for lifting this thing when you get supply pressure effect and stuff. So yeah, so we take that so people won't accidentally adjust it and stuff like that. So quick and easy solution or you get into complicated stuff going on.
Oh yeah.
With valves, and relief valves and stuff. So this is a kind of solution for that. So, well, we're done with that question.
Yeah.
Okay. I'll get the next prop.
Okay. What is it? Oh, it's tiny. That's right.
Okay. Today we tested the flashback arrestor 6103A for the first time on a hydrogen tank. It turned out that it's not working. It does not let the gas out. Please help us with this. Not sure if the arrestor is faulty or not.
Now, I was, in the question, I didn't ask this. I was curious about how they tested it. Did they set off the flash arrest back? That's one of the things I was curious about, but I didn't get back. They didn't get back yet. So I had a few questions because you have to put the flash arrestor in properly. First off, there's an arrow on it. You can
zoom in. You won't see it.
You won't see it.
It's etched in there.
It's etched in there, and so you got to make sure it's going with the flow of the gas that you want it to.
Just keep it
to do. Yeah, and so so that's the first thing.
On the camera.
Yeah, full view.
That's
now the next thing is there's a green ring around it, and you should.
So which way is the arrow pointing?
No, the arrow points this way.
That way. So you go in the bottom. Oh, go in.
You go in through this way.
Yep.
And then if it's off, or if it's correctly, you should be able to see this little green strip around here. If the flashback arrestor goes off, it'll trip, and it'll hide the green ring. So you want to set before you put it on there, else it won't, or else it won't flow. And then also you want to make sure that the gas is on. I know this seems, but sometimes people forget the most trivial things when you've done something 100 different times. You know what I mean? So to make sure the gas is on, make sure there's at least half a bar, 7.25 psi, which is the minimum.
Oh, okay.
Which is the minimum pressure to flow through here. So not too hot, but you want to make sure you have enough pressure.
Yeah. So if you had low pressure, you wouldn't.
Too low pressure, it wouldn't flow either. So those are some of the things to check when you're putting in there. That's about it.
Yeah, there's some but you think, oh, okay, just flashes. But this has a check valve in here, so if you got gas going the wrong way, it won't flow back. And you got inlet filter.
Hey, that's why the arrow. I should have mentioned the check valve.
It's got a flame arrestor. It's a stainless steel flame arrestor.
I like to call him a flame officer.
It's got a thermal cutoff. Oh boy. So that's it. So we'll go to I think we can squeeze in the next one. Some cool graphics on this.
Oh yeah, this one's interesting.
I have a piece of equipment that uses a Matheson flow meter, and I'm trying to understand how to read it. It's the model FM1051. It's an Arabic numbering system.
That's true. It was an Arabic numbering system. It wasn't the English numbering system.
Okay. If you've watched your videos, thank you, on how to read a rotameter. So it'd be read a rotameter, right?
Right. Yes, they forgot.
But the confusing about this one is the numbers go from 0 to at the top. What? To 100 at the bottom. Sounds weird.
It does.
Evenly. Okay. Looked around. I've been unable to find a data sheet for the exact model or any other information on what operations. Go in the opposite direction of what I expected. Here's attached a picture. We're going to show that. Disregard the superimposed INP scales. Those are not.
Those are
edited by the equipment manufacturer. So, next graphic. Ta-da! That's a photo they sent. It's an aerosol generator.
Yeah, you can see the 98 at the bottom. You
Yeah,
can't really see the 100.
We're going to zoom in on that. Not yet, but yeah. So this is on. So we sold this to the company that makes this equipment.
They added our rotameter into their design,
which is great.
Which is good. We love that.
And so we do a lot of custom scales for people, and they probably go on other instruments and stuff like that. Yeah, and the part number they gave us for the rotameter, I looked, and this rotameter is older than 1993, because in 1993 we went to a different numbering system for our rotameters. So this is old.
From Roman numerals to, is that what happened?
Okay, you want to put up the next graphic? So this is 0. And they also have we didn't add the I's. That's an I and a P and a 1 and a 2. And so I see, because the flow goes up, a float that's heavy,